Hello, hello everyone, and welcome back to Stationeers. I'm level 36, and we're back on our Mars survival world. Last we were here, we finished up our solar array, got our batteries wired in, and have a lot better situation when it comes to our station's power. Eat that real quick. Top left on water. Some lot of baked potato. Still living that Mark Watney potatoes life here. We take a plant and then let those finish turning into seeds. So, today, I have some big plans for this video. We're going to continue improving our base by conquering a rather large but important project. That project being an old nemesis of mine, the furnace. So this has been our furnace setup, and it served us well in the early game. But we're at the point where we're starting to need super alloys, and honestly, operating this thing is so much more of a pain than it's worth. So to build those super alloys, we need an advanced furnace. So you can see here, if we go to our ingots and any of these super alloys, it only can be made in this advanced furnace. It cannot be made in the basic furnace, and operating this is a pain. We have the power of automation and better tools. So between last episode and this one, I did some resource gathering, got some stuff made in our printers, and put together all of the materials we'll need, bar one, for a automatic, fully electrically controlled advanced furnace. The only thing we have left to make is the actual advanced furnace. Should be the only thing we have left to make. Do have some notes written out, all the stuff we'll need. Looks like we need gold, copper, steel, electrum, solder, and silicon. Need gold, copper, steel, electrum, solder, silicon. Should we all? Yep. So now we can actually make our advanced furnace. So this is, I'm going to be kind of doing this as a bit of a tutorial and a bit of a, bit of a tutorial and also installing it in the survival world. I'm following along with a guide that was put out on Steam. It's based on I believe it's the Cows Are Evil design for the furnace. Also, a quick shout out. I'm sure most of the people who watch this channel are aware of Cows Are Evil and their videos and their channel, but they have a awesome Stationeers channel with lots and lots and lots of videos covering all topics of tutorials and some really fun playthroughs as well. Part of the inspiration for me starting this series is their videos, so go check them out if you haven't. But before you do, finish this video. Watch this one first, then you can go check them out. But seriously, no, they're a really great channel. But we're going to be building that design, so we're going to be using some IC10 controllers to automate our furnace to allow us to select which ingots we want to build, and then have the computer figure out the appropriate gas mixtures to make the ingot, all the way from our basic copper, iron, silicon, all of that, through our advanced, our normal alloys, and even our super alloys. And that will unlock the ability to build bigger batteries, more things, more advanced stuff, and just generally make the process of building alloys much faster, safer, and easier. Or hopefully safer. We'll see. I am going to try and go at a fairly good pace this video because I'd like to have the whole build in one episode. So, start off, I flattened out a little area over there that we're going to build in. And we are going to need some frames and some steel sheets. I need iron sheets. Some iron sheets to put down a little base for our furnace area. So I figured we'd do it right across from our gas refining as well. We'll need to plumb the gas over there. I realized as this series has gone on, this gas setup is pretty less than ideal. So I am going to probably, at some point in the future, rip all of this out and redo it. But today is not that day, so we'll get to that later. We'll need to tear this guy out of the way as well, but let's just start off by putting the frame down. So we'll go over to, say, there. We need our furnace right here, so that one. This build is fairly compact, but I like things to be symmetrical, so I'm making it probably a little bigger than it necessarily needs to be strictly, but it's the way I want to put it together, so it's alright. And we'll just weld these up. We're going to go to stage 1 for all but one of them. So while our automatic ingot delivery system is more of a convenience automation, I'd say that an automated advanced furnace is probably one of the most important proper automation tools to make life in Stationeers much simpler. Alright. Well, I trapped a expired filter in my frames. Just grab that quick. Eventually I'll get some recycling set up as well. You might notice that my lighting is following me. So it turns out you can actually put a portable light in your suit pocket and it will just show the light around you. So thanks for the suggestion in the comment section, and thank you all who have been watching this series. I've enjoyed seeing the comments, seeing the interactions with the videos. I've really appreciate all of the support and the interaction that I've been getting from everyone. Means the world to me, really. Just doing this for fun, and I'm glad you seem to be enjoying it as well. So, now we have our base frame laid out. So we will be placing the furnace right here, and then all of the support systems to make it all work will go around it. For this design, I am going to mix the fuel on site instead of using pre-mixed fuel like over in our atmospheric setup, just because that makes life a lot easier. Well, not necessarily easier, but it makes it so that I don't have to worry about separating the mixing and the furnace, and also I don't really have space in my atmospheric setup, so that's as good a reason as any as well. Alright, so for our setup, we are going to actually need that. We're going to need our furnace kit, some electronics parts, and some steel sheets to actually build the furnace. Then we'll also need some iron walls and some glass sheets to build our furnace enclosure. So I'll go into a little bit more of how this all works as we get through it. But our furnace, our advanced furnace, has to be enclosed for this to work properly. So we'll place it, so if it was centered on the block, it would be right there. We're going to move it one forward so that the interface of the furnace will stick out of the sealed cube we're going to put together here. And then we're going to need our electronics parts and steel sheets along with welder to put that together, and then it should just be a screwdriver to finish it off. Alright, so this is the advanced furnace. And the major difference for the advanced furnace is not only can it build superalloys, it has a volume pump on the inlet and the outlet. So in the back we have our input and output gas fittings, and this has an ability to pump those gases in and out at a set rate, which is very useful for getting the right pressure and temperature, because those two things are linked, for creating whichever alloys you're trying to create. So what we're basically going to do is set up enough infrastructure that this can feed itself with a fuel mixture and a pressurized coolant gas so that it can achieve that ideal pressure and temperature for each ingot based on a selected ingot hash using a bit of some code that is written to do all of this. All the code that will be used in this video is available in the workshop. I didn't write it. I'm just taking advantage of the wonderful work of the people who came before me. But yes, this also does need to be enclosed so that it can be done in a controlled environment. And we're going to use windows to do it because they look the best of the options of walls we have, and it makes building a little bit easier. So we'll place down all of our window frames to start, and then put them all up to their first phase, which is just the iron sheet, to get them initially constructed. Then we'll grab our glass sheets and put our front glass on, and if we can get the angle right, we'll do the top glass as well. There we go. So now we have front glass, top glass, but we can still get in and around the furnace on the sides. The advanced furnace has its input and output on the sides instead of the top and bottom, so it makes it a little easier to get materials in and out of it as well. So, besides the advanced furnace in this little box, let's go over what all we need to make this automatic. So this is by no means the simplest advanced furnace setup. In fact, with the advanced furnace, you can still feed it ices manually. There's a table on the workshop of the right ratios to put in the various ices for making all of the various alloys from basic to super alloys. While it's possible to do that, I definitely think it's worth the investment to spend the resources to build this setup here or something like it. This just makes the whole process so much easier. As far as atmospherics components go to feed the gases, we need volume pumps and pipe analyzers, along with several insulated pipes, some canisters, and portable gas tank connections, 2 active vents for pressurizing and depressurizing the room itself. And that's really all we need from the atmospheric side, besides since we're doing the fuel mixing over there, we'll grab the gas mixer from the old furnace setup. Then for electronics, you need a set of switches to select your ingot, some IC housings to house the ICs. We use 2 ICs in the setup, an IC hash and an IC furnace. Some consoles to display various properties along with the ingot that is selected, and then the 2 ICs to run the code, along with a hash display IC or a hash display board, and then 4 gas display boards so you can see the furnace information. You also need a computer and an IC editor motherboard to code these 2 ICs, and some chutes to get your ingots and ores into and out of your furnace. I got a transformer because we're going to put this on its own circuit network, and a sensor for some optional readings that we can grab. Additionally, we'll grab a light. I think I have some lights inside the house, or the hab, that we can use to see the status at a glance. So let's get right into it. We are going to need, so we can put these back for now, some pipes. We'll start with the atmospherics, so we'll need our volume pumps, some pipes, our pipe analyzers, and tanks, and tank hookups. That should be a good start for our atmospherics. So with our old furnace setup here, what we were doing to control pressure and temperature is we would put in our oxygen and volatile, so hydrogen and oxygen mix. It would get mixed here to a 1:2 ratio, stored in this little pipe / tank setup. We'd set a pressure regulator to set the starting pressure in the furnace, and a back pressure regulator to set the max pressure in the furnace. Turn it on and hope. And then we'd have to play with these values, release gas, push more gas in, reignite, do all of that until we got the pressure and temperature pretty much where we needed it. For simple ores, or for simple alloys like steel, that's not a huge deal. It is a super wide tolerance for where you can have things. We can actually take a look at real quick. So for like steel, you'd have your temperature anywhere from pretty cold, 900K, all the way to really hot, 100 kilokelvin. Obviously not actually cold. 600 degrees Celsius is quite toasty. And your pressure anywhere from 1 to 100 megapascals. Pretty wide range of available pressures and temperatures. But for some of our more finicky alloys, right, we were looking at pressures and temperatures that are much more controlled. So 20 to 100 megapascals on that one, so a lot higher pressure. Or let's see if we can find one that's, yeah. So solder is pretty finicky, so the pressure is pretty wide range, but the temperature has to be super specific, otherwise it doesn't work. So this was just a bit of a pain. Making all of those alloys, as those of you who have been watching, was really not very fun. This will automate all of that. And the way it does that, and this will be a bit better of a demonstration of what I was saying before, so we actually are going to have two gas feeds. So this is the input to the furnace. We are going to have an angle there, and then a T-piece. And throw an angle up here. So in this bottom inlet, right here, we're going to feed our fuel mixture. And then from the top, we're going to feed an inert coolant gas. So the bottom pipe feeds in the volatile fuel mixture that the furnace can burn to set its temperature correctly. And then the top, we feed in that coolant gas, which helps not only cool the furnace if we're a little too high on temperature, but it can assist in pressurizing the furnace to just the right pressure. So we can use the fuel to get the temperature and the coolant to get the pressure and more precisely control the temperature. To do this control, we're going to use some volume pumps. So these just go right here. Then we need some more pipes because we're going to need to put on some pipe analyzers. These will tell the computer all about what's going on in those pipes. So it knows how much coolant it has available, how much fuel it has available, what the pressures are all at, so it only opens these just the right amount to get the gas mixture we need. Additionally, like I said, we are going to be doing our fuel mixing here on site. So we'll pipe that down and pipe that forward towards us. And we're just going to grab our gas mixer from over here. No point in making another one when this one will work just fine. Oops, step there. So our hash IC, I believe, actually takes care of this as well. So we need to plumb in some oxygen from the side and some hydrogen from the bottom. So this will mix our oxygen and hydrogen at the ideal mixture for not only the pressures but the temperatures that we have. So we'll always get the ideal fuel mixture. Oops. And to do that, we also are going to need some readings. So this gets its own set of pipe analyzers. So to supply gases, at some point, we will be running pipes from our main atmospheric setup over here to fill up the tanks over here, but I would like to have some separate tanks over here to run this setup. So we'll need to place those where we can somewhat get to them for now. Well, let's put down these containers and we will plumb them in. So we're going to need... Oh, we will need to also put another pipe in there. We want to have some kind of a buffer for our fuel. It'd be nice to also be able to just use this as our fuel mix. It's this being difficult about its rotation. There we go. So we'll put that there. And then we'll put our coolant canister there. So we run wrench. So that's our fuel line. This is our coolant line. Stack of insulated pipes. So our pressurized coolant gas, I think we're going to try and use nitrogen in this case. And then our fuel mixture, this is more of a buffer tank, so this is going to start off empty. So in fact, we can actually put that one there now. If I can get on my platform. Hold one of these. And nudge it up onto the stand there. Connect that. Alright. So, we have our empty portable gas tank, which is our fuel tank. We'll actually label that real quick. Portable fuel tank. We do already have a tank of fuel, but I wanted to do this one separately. This is going to be a fuel connector. This one will be our coolant connector. We already named these. So these do require specific names. Let me grab my notes real quick. Alright. So for the scripts to work, we need this one, which is our coolant pump, to be named coolant pump. And this one is fuel pump. You can also change the scripts to look for the different names, but it makes sense to just use the ones that are pre-coded into there. This is going to be our fuel PA. This one is going to be coolant PA. So these are our fuel pumps, fuel pressure analyzer, coolant pump, coolant pressure analyzer. This is our fuel mix. This one is our O2 analyzer. This one is our H2. And then our furnace itself needs to just be named A furnace for advanced furnace. Alright. So, now that we've got that, we need to place down our other connectors. So this one is for our oxygen. I'll put it right here. And this one is for our volatiles. I'm going to put that one right there. And plumb these in real quick. So at this point, we have the plumbing for our pressure gases done. Or not our pressure gases, our fuel gases done. Fuel and pressurization gases. We just have to get the containers over here when we're ready for that. But we also need to pressurize this room. Theoretically, we could use our coolant gas to pressurize the room, but you do want to keep them separate because the room needs to be... It's going to get a lot hotter, and you just kind of want them to be on their own separate circuits. So we're going to actually have a separate canister, because I think we're going to try and use CO2 as our room pressurization gas of choice. And for that, I'm going to put a pipe here, a T-piece here, and a angle piece there. And then our last connector right, the gas one, so we'll put this here just for the sake of symmetry, and then that right there. So now we have all of our tank connectors down. This is where our active vents will go to pressurize the room. But first, let us also get a way of exhausting our waste gases. So we're going to send those out of the... let's actually do that in a moment. I want to get those... want to get those active vents in place first. So let's grab some glass so we can close up this back panel. We'll also run inside and grab some water so we're not dehydrating ourselves to death. The helmet, cup, and eat some food as well. Right. Alright. So, let's grab some glass sheets and our active vents. And we might as well grab our sensor because we'll need to put that in that room as well. Along with our chutes so that we can plumb the input and output from the furnace. Then we should be able to seal up that room. Also tear down this on the way back over. Grab the glass. Build up that rear window. Grab our active vents. So one there, and sensor kit. Need a gas sensor right there. So now that will give us our sensor reading for the inside of the room, and then our input and output vents. Chutes. Let's throw a... We'll get a better, like, actual placement for these in a moment, but put that there, and that one there. So this is now all of our inputs and outputs plumbed into the furnace. Technically, we can seal off... Oh, actually, no, we have one more. That's right. We wanted to do our exhaust. We do need to exhaust from the furnace still. So we'll take our exhaust up one, and then over and out. We still do want to keep it in a insulated pipe because this is going to be very hot exhaust. And we might enclose this all and make it nice and pressurized, so we want to be able to get it out of the pressurized heated, cooled environment before we toasty up the rest of the station. We'll just grab those last few pipes to do that, and then we'll want to vent this somewhere safe because, you know, very, very super hot gases will be exiting this, so preferably let's not put them anywhere nearby where we're hanging out. Was this a potential waste of some of these pipes? Probably. But he gets it out of the way. I probably could have gone quite a bit shorter than that, but for now that's fine. And we'll need our pipe cowl, and then we can get on to the wiring. So that will vent any of the exhaust gases well away from all of our expensive and sensitive components. So let's grab our... So we need one more wall piece so that we can do this wiring properly. Iron walls. Need our switches, our IC housings, our consoles, and some cable coils. So this wall, going out here. We're not gonna finish it off. This is just a frame to hold all of our displays and buttons and stuff on. We're going to grab. I am gonna need a. Let's see. Console. So these up here. I will need 1, 2, 3, 4 consoles. I have... Maybe we'll leave that one as well. So we'll just grab... Oops. Consoles like that. Then we're going to need our logic switches. So these at the top are our monitoring consoles. These tell us how our stuff's doing. Actually, we might be able to even, if we want it to be real fancy with this, even easier. Oops. It's angled consoles. There we go. So now they'll face down at us a little bit. This one is where we'll see our selected ingot, and then to do that selection, we're going to get a dial. And don't touch that dial. We'll be right back. Not actually. We're still here. So we'll need a dial.
Waste tank caution.
We're going to need a button to activate the whole thing. And then we need 2 levers. So one lever is going to vent the furnace, and the other lever will vent the chamber as a whole, or the chamber and not the furnace. So that one there. So that is all of our control panels set up. Now we need to put down our IC housings somewhere a little bit out of the way. Honestly, I'm realizing we can move this over to the other side and compact this even more. No, we don't want to do that. That is probably getting a little bit of the unnecessary compact at this point. We're just going to put these somewhere generally relatively accessible and kind of in line with where some of our wiring's going to be, which is right back here. So these are where our IC10 chips are going to go in the long term. And let's see. We do have to wire all this stuff, so this has all been named. We will need to name those gems real quick. Which ones which doesn't matter, but they are needing to be named. This is going to be vent 1 and 2. It's going to be spare gas sensor. This one, I don't think the name actually matters for. Probably not. Perhaps. Actually, let's check real quick. No, I don't think it matters. Okay. So, that's fine. This IC housing is going to be our hatch. Or actually, no, these are importance. This one is going to be hash IC. This one's going to be IC. There we go. So hash IC, furnace IC, a furnace, vent 1, vent 2. Coolant pump, fuel pressure analyzer, coolant pressure analyzer, fuel mixer, O2 analyzer, H2 analyzer. Let's just name these. O2 connector, H2 connector. Then we need to name these. So the dial is going to be the ingot dial. The button is going to be the confirm button. The output lever is going to be flush. This one will be vent lever. There's one more piece of electronics we'll need before we can start wiring all this up, which is just the light, which I'm pretty sure is inside. Should have grabbed that while I was in there. Let's just vent my waste tank real quick. Yep. Have some lights in here. Let's just top off the water while we're in here. Alright. Need a LED. Alright. So now, we can wire this monstrosity up. Well, first we should actually put in our chipsets and put glass on all that. Then we can wire the monstrosity up. That, that, that. Four of those for now. Don't technically need to get out of this right now either. So this one is where our hash display will go, and then these four up here each get a gas display. So the first two will show the values of the furnace. We could also just look here, but it's nice to just have them displayed here, and these two will show the values for the room. And close all of these up. Now we should also be able to, we'll just leave it open to do the wiring real quick, then we'll close all that up as well. Speaking of that wiring, so I'm going to use heavy cable right now. Not terribly sure if it needs it, but I would rather just use it. It's what I did when I prototyped it out. I've seen it in a couple of the guides. I know that some of the stuff, like the furnace, requires quite a bit of power draw. Since it needs to all be on the same logic system, and I don't want to mess with logic mirrors, I'm just going to bite the bullet and use heavy cable. Probably not the most efficient choice, but we'll live. Need one of those fancy sideways connections like that. Great piece. Up. Go. 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 So wiring each of these in. So this is our analyzers, our gas mixer, analyzer, so fuel pump and analyzer, coolant pump and analyzer. I need to grab those three back there. Okay. Down here. Put all this in. So our IC ports wired in. Then up front. Also may need one more cable going around to the top. Or we can just go the long way around. Need say just one of these. That there, there. Next stack of cables. It's ugly. I want to just do that. So we'll go up around the top on the other side. Again, probably not the most efficient way of doing that, but some things must be sacrificed for aesthetics. And I did have some leftover heavy cable from the solar build, so I figured I'd just use it up here. I know I'll need it again later, but for now, this will do. I might actually need a little bit more to go from over there to over here, so it will be fine, though, I'm quite sure. We will need to also wire in our computer. But theoretically, that's the required items plumbed in from the wiring standpoint. So we've got our furnace connected, our sensors connected, our valves connected, vents connected, those connected. It all is looking pretty good. I think we can actually seal the room now. We shouldn't need to get back in here. If we do, it's not terribly hard to. So that's that wall done, that wall done, that wall done, and then this wall done. So it's in its own sealed atmosphere. The furnace is trapped. And don't need the glass anymore. So tear this apart real quick while we're here. We'll Alright, and need a hand drill and an angle grinder to tear the rest of this stuff out. Alright. Up all of our pipes. Strewn around. We could actually probably replace a good section of that with this basic orange pipe, yellow pipe. Be a lot cheaper. And just as good. Ooh! Storm! Alright, well, I'm glad I wasn't moving a bunch of stuff around just then. So this all, in theory, should be fine in the storm. Let me just make sure I don't have anything loose hanging about. Nope, doesn't appear that I do. So I'll weather this storm real quick over in our hab, and then we'll get right back to this. So I have no desire to be building in the middle of a sandstorm. Those in there with our existing extra pieces of plumbing. Grab our potato seeds, and hopefully this will be done in a moment. Big good amount of potatoes we've got here. those in there, so we're using up the old ones for growing new ones. I'll have to build a better greenhouse once we get some more pressurized areas to get all of this guff out of our main pile of stuff. Eat some baked potato. There's water. And I'll see you all when the storm clears. Alright. Storm just cleared up, and we're good to get back to work. Luckily it didn't last too long. Excited. We're so close to getting... never having to think about those old army furnaces again. We just have the new one to work with now. So the advantages, I mean, there's a lot of advantages to the advanced furnace besides just the ability to make super alloys. But it's just, with this little bit of automation, it'd be so nice. Alright, so, we've got our pipes set up. We've got our wires in. We've got all this. We need to flash our ICs with the codes. Let's go grab them. And we'll need to grab some power with it as well. So here's our two IC10 boards. Grab those in a bit. We're going to need our computer, IC editor motherboard, and most likely some more cable. Do we have any more kicking around, or did I grab the 2 coils I have spare? I think I might have grabbed my 2 spare coils, and we'll need a transformer as well to isolate this. So let's go over here. We've got power coming up right here. So it means there is underground power right there somewhere too. Let's just this apart real quick. Clear up some space for our new run. This off for now. That there. Yeah, we're gonna need some more cable coils. Let's make those real quick. Always good to have some more anyway. To continue our theme of building subterranean cables, I'll have to rip up this one spot real quick. Keeping our high voltage line nice and out of the way of any surface machines we're building. Tuck it in out in the corner here. Yeah, thought I queued up some more. Then we'll toss our transformer in. That provides the ability to toggle this whole assembly on and off, and some logic isolation
Air tank low.
as well. Grab some more air here in a second, but we should have some more heavy cable coils. Go. Hopefully, this will be enough. Close the distance. Alright. Get our computer. Throw this. Right. Where do we want it? right here for now. Just need a screwdriver to finish that off. And our paper coils to in. Toss in the motherboard. And we are good, could be good, to try and turn it on and flash our ICs. Let's see, let's set the power to, I don't know, 1000 watts. Kick it on. There we go. Let's turn all this stuff on. So we have our IC10 chips here. Let's toss those into their respective housings. We could set up a little programming station and just program them all back at the base and then slap them in here once they're ready. But for now, we'll just leave a computer here and move it when we need it. So starting out, we'll do the hash IC. To do this, we're just going to go to Edit, Library, and you'll see this is the workshop IC that I have here. Import that, overwrite our whole bunch of nothingness. And you can see this is where it's defining the stuff up here for the code for a dial, button, lever, vent, hash database. Even set up the mount dial, override, furnace sorter, vent lever. You can see all kinds of different things here. So the programming language that's used in Stationeers I find super interesting because it's very similar to assembly. So you can see jumps, moves, all of this, and it's pretty dang cool. You can see here all of the different commands for vent 1 and vent 2 and how it all works together to make this work. So we're going to confirm that, and we're going to export it. So now the hash IC, if we come over here, this one, yep, you can see it's been written with 3084 bytes. And then we can switch to our furnace IC, edit it, library, furnace IC, let it overwrite that, and this is the one that does the actual control of the furnace. So you can see our pressure analyzers, those names there. So if we did have something misnamed, we could adjust it over here. All of this information here. Write that to its IC, so furnace IC export. So now both of our ICs, our furnace IC and our hash IC, are written. They have their respective code in them. We can turn them both on. Now we should see, well, a whole bunch of nothing. We need to configure some stuff first. So if we grab our data disk, here, look for our hash IC. Shows nothing, but if we start cycling through this, we have our ingots shown over there. Those are all the varied ingots that this system can produce, and then zeroes out as nothing. So up here is just some pressure and temperature monitors. So we're going to do this one. We're going to look at the pressure of our advanced furnace, the temperature of our advanced furnace, the pressure of our chamber sensor, the temperature of that. So now we have the pressure, temperature of our furnace, of the outer chamber there, our hash IC, all of it appears to be working. So last up is just to do our ingot intake, or our ore/ingot intake, and our outlet over there. And then fill up our gas tanks and get all this plumbed in. So we're going to need oxygen, H2, so hydrogen, nitrogen, and CO2 is I think what we're going to do. So now that the electronics are all configured, everything is good to go. Let's grab the rest of our tanks. And our ducts. That's the other stuff we need. Some extra ones up here as well. Here, this one's going to be pretty simple. We're just going to grab a chute inlet. Orient it the way we want it. It will go right here. Just 2 corners to get us around there. Then this one, since we have so many electronic bits right there, we'll have to do this one a little differently. We're gonna actually come up. One more out. That's already aimed. Okay. And an outlet, so it'll drop it right there for us. Eventually we'll plumb it into our ATM system and all that, but for now, that'll work. Oh yeah, our air tank was pretty dang critical. And now that we're over here by our atmospheric setup, we can grab our various pressurized gases. So this will be our hydrogen, our nitrogen, so our coolant, and this will be our CO2, and then we already have an O2 tank right there. So I guess, well, we could use another one, but that one, we'll just use that one for now. I'm going to be a little bit careful about this. I don't want to rush this stuff, so we're going to fill these to their respective pressures. Let's turn on our power to this whole assembly. I'll leave that on right now. Turn this off so we're not overpressurizing that. I want my tablet. So this is one of the reasons this gas system isn't great, is because there's some possibility of bad things happening if we're not careful. I should have built the whole system with some more safety checks or in it, so that if any part of it was to overpressurize, it would all go. It would empty out the vent stack, and we wouldn't have to worry about it. But we didn't do that, so we are where we are. So this is volatiles. We want to put the volatiles in the gas tank, and to do that, we are going to use our volume pump. So that one has started. We're going to turn this one off. This is our nitrogen, right? Nitrogen. So to do this, we'll do that. We are going to skip out on our... We're just going to do 2 at once, because pressure gases are where things can go wrong very quickly. So we want to make sure we're using the utmost care when filling up these tanks. We got a decent amount of gas, so we're not doing this all the time, at least enough so that until we run actual pipes over there, where we don't have to deal with it. Those two are running nicely. CO2 is the one that's going to be the real pain, because CO2 has such a low condensation pressure, or a low condensation pressure compared to these two, where filling this up could become hazardous and very... I'm also going to turn these off unless we're actively trying to pressurize those tanks. They will save us some energy when we don't have the whole thing toggled off. It stops it from pumping gas just into that pipe. Alright, volatiles are almost there. Nitrogen's taking a little longer. We had a lot less nitrogen. We only have 2.7 kilomoles, whereas we have like 5.6 kilomoles of volatiles. So up to about 5.37 megapascals in the tank. Go up to about 6.5, I think is what we'll do. Close enough. You've still got a little ways to go, so put you. Grab our canister of hydrogen and ungracefully just kick it over here. Try and get it actually on its connector. Well, that wasn't quite on there. It'll hook up. This is our H2 connector. This is our H2 tank. It's going into the H2 side of our network. Back that. I think we forgot to name our LED. What does the light get called? S light. There we go. Now it's doing what it's supposed to be doing. Turning red. Going muted. System is not ready to operate. So we've got hydrogen hooked up. Look at this now. Doing something with all of it. That's a little bit concerning. Why are you set to 100%? Let's turn this whole kit off for now. Hopefully that didn't cause issues. And let's see how good this code is. Let's grab our oxygen tank next. How's this one doing? Still filling up. Turn that off. Turn you on. Take terribly long. Should just be pure oxygen. I might, as much as I hate to, I might just vent that tank to atmosphere. I don't know if the ratio is going to be good anymore. That's a pain. Well, good thing to note, if you're using these scripts, make sure you have all your tanks in place before you try and do anything. I guess that's kind of on me. Should have probably done that before I hooked all that up, but I don't like having these just kicking around, doing nothing. It's precarious. has the opportunity for unexpected explosions. Check that. So now we have... I guess we can just see what it does to start, but we'll see. Yeah, that mix is pretty well not correct. Let's save what we can. I think we're just gonna have to... We don't even have a way of suctioning it out. Well, we'll do the best we can. Which is to haul this off a generally safe distance. And vent it all to atmosphere. Was that maybe strictly necessary? Oh, good. It does actually vacuum itself out, even though we're a planet with an atmosphere. That's maybe a bug. I'm not supposed to be able to do that, but I'll take it. It made my life easier. I didn't have to set up a whole vacuum setup to empty our misbegotten fuel tank. Alright, let's get the rest of our tanks. Oh, we forgot about this one. How's it doing? Ah! Almost perfect. That worked out nicely. So you should be full of nitrogen gas. Yep, you are. Drag you over. Pick you on the coolant port. Eh. Now we've got fuel mix, nitrogen, volatiles, oxygen. Might grab some more volatiles real quick because we did dump most of it into the atmosphere, unfortunately. And while we're waiting for this to recharge, we'll deal with our favorite friend. Ah! CO2. I do not like transferring CO2. It's kind of a real pain because of its tendency to just turn into a liquid. So we're only going to use a little bit because we only need a little bit.
Hydration critical.
Let's just go for it. I use 5 liters. That's off, so we don't have to worry about that. And we're going to just super carefully monitor CO2 in the network. Volatiles. Nothing condensing yet. The last thing we want is this to all turn into liquid and then to blow out the pipes because the stress goes through the roof. Honestly, probably enough. But we'll push our luck a little bit more. You're alright. Do 550 moles. That should hopefully be enough. Alright. Disconnect that. Then we'll grab a drink before we kick this whole thing off. Grab some ingots so we can test it out. Ah! Get on your home. Close enough. You're full of... You should be full of CO2. You are... Oh, my light just went out of power. Okay. Use our helmet light for a little bit. And let's grab our volatiles tank. You in your home. Alright, now we've got volatiles in there, we've got oxygen in there, we've got some form of gas mix in there, got nitrogen in there, CO2 in there. We'll turn all this on. Actually, got a drink. Hey, there's a light back on. Back in range. Another thing we'll have to do soon is recharge our room here with some CO2, because our room is actually starting to get converted mostly into oxygen, which is good for us, but not great for our plants. As you can see, we're down to 10% CO2, which is still fine, but I think it actually puts our plants into a moderate growth stage instead of a, like, super happy. Oh no, it's thriving. Okay, good. Less pressing than I might have thought. So helmet up and head outside. Alright, so technically, if my calculations are correct, this should be good to go. Turn that on. Pressure in the room is rising rapidly. (101 kilopascals, that's what it wants to be at. We still have plenty of CO2. This should be a closed circuit, so this should never need any more than it already has. Temperature in there is nice and chilly right now. We'll be making plenty of gas mix. Alright, what do we want to make? Should we go straight for the hard stuff, or do something simple first? Let's look at what we've got in the system. I think we might need some more electrum. We've used a lot of electrum recently. Yeah, we're solder, actually. Solder, and that was the one we said was difficult. So let's take a look. What do we need for solder? Ingots. For our simple alloys, solder. We need iron and lead. So, let's queue up some solder and grab a stack of iron and a stack of lead. Got plenty of lead. I don't actually have any iron ore kicking around right now. I think I combined all my piles over here into big stacks. Just grab my drill. It should only take a minute to find some. Just for the sake of an example. So excited to get it already. I consider having materials to melt. I know I could just grab some ingots, but now I have this set to flat right now. Oh wait, I haven't plumbed into my... That's fine. We're alright. Don't need to worry about this. because I have it set to the stacker, so I can just grab iron all of this off, then me some iron. Spit it out in 50 ingot stacks. We're going to make a bit of solder. Do not need this much, though. I would also like to make some more steel. So we're going to grab, because for steel it is 3-to-1, and for solder it is 1-to-1. And then let's see if we can make some stellite. So we'll start with solder, then we'll do steel, then we'll do stellite. So we need, that's our solder recipe right there. 1, 2, 3. The rest of these can go back into the system. Okay, have some coal. So we have enough iron for 200 steel and enough for a iron and lead for our solder. So let's pull up our solder recipe. This requires iron and lead. So theoretically, we have solder selected. We hit that confirm button. Should be doing things. Yet it is not. Pumping stuff in. I have to turn this on manually. Oh. Then the whole thing shorts out because I didn't give it enough power. Give it 2,000 watts. There we go. That's looking a little bit more like what I was expecting. Let's toss in our lead. And our iron. Solder. Done. That was so easy. Now, if we turn that dial up to steel, hit that button, light turns green, coal, iron, iron, iron. Venting some stuff up there, so that's why we put that vent all the way up there, because those are hot furnace gases. 200 grams of steel. Alright. That's pretty awesome. Now let's do the final challenge here. Oops. Throw those into the thing. Our first super alloy. Stellite. Silver, silicon, and cobalt. So I have some silver ore. I have some cobalt ore. So what ratio do I need? I need 50 of that, 50 of that, and 100 silicon. So we're going to grab silicon, unless it's all in this machine already, and it is. Push that. Send it all back around. Off. Getting everything. Silicone. We will definitely have to get a better way of feeding this system, but just having this as a capability right now is super, super exciting. Left in there too. Go. That's all put away. So let's make some stellite. Oh, it's so cool. All the way. Stellite ingots. This one might shoot some flames. Did when I did my test at least. So it's getting everything ready. Cobalt, silver, silicone, silicone. Yeah, there's the flames. Oh, that's a little closer than I would have liked. Jeez. Maybe I should move that even further away. But there it is! Super alloy. And hopefully it's not melting itself in the process. Did we singe anything? I don't think so. That was a bit spooky. But yes, our first super alloy. Stellite ingots. That's pretty cool. Did I only make 50? That's a lot of materials for just 50 stellite. I realized that whatever. I realized that was at such poor efficiency. But yes, that is our furnace set up. And I think that that's pretty cool. Did we burn through all of our gases? No, we didn't. You recharging? Yep, very slowly. Yeah, we definitely have to get some better gas mixing set up so that we can, or not gas mixing, but gas filtering set up so that we can keep this all ready to go, because it's going to chew through gas with no abandon. But it's super automated, which is super cool. Anyway, turn that off. Don't need it right now. We'll leave it hot for now, because there's no point in venting everything in case I do need to make some more stuff. But our first... So I get through all the silicone. Oop. Our first super alloy in the machine. Oh, it's so cool. That is a huge step forward. A huge step forward for our base. Automated furnace. IC10 control. We ought to do some improvements to our gas filtering. Definitely some improvements to our hab and our living space here. But that will make all those improvements so much easier to execute on. Oh, head inside. Well, that's exciting. I'm looking forward to seeing what I get up to next, and I hope you are as well. Thank you all for watching. I do hope you've enjoyed and found this somewhat informative. If you did, be sure to drop a like and subscribe to see what I get up to. I post these videos every Tuesday. So, have a wonderful day. I've been Level36, signing off.